Now that we've figured out the two special trig limits, we're in a position where we can find the derivative of sine x. So of course the derivative of sine x is going to be the limit as h approaches 0 of sine of x plus h minus sine x over h. And of course what we're going to do in order to expand this first term, of course, sine of x plus h does not equal sine of x plus sine of h. In fact, what we need to use is one of the angle addition formulas that you learned in pre-calculus. And the angle addition formula gives us sine of x plus h equals sine of x cosine of h plus cosine of x sine of h minus sine x all over h. Well, now we're going to do a little bit of rearranging here. We're going to bring the two sine x terms together. We get a sine x cosine h minus sine x. We're going to have that over h. And then separately, we're going to have a cosine x sine h over h. In the first one, we're going to factor out a sine x, and what we're left with is cosine h minus 1 over h. In the second one, we're going to factor out a cosine x, and we're going to be left with a sine h over h. And this is, of course, why we needed these special trig limits. We see that this one goes to 0, and this one equals 1, so that the limit is simply cosine x. In other words, the derivative of sine x equals cosine x. And if you look at the graph and you look at the slope of the sine graph, you can very readily convince yourself that the slope of the sine graph equals the cosine graph. This is an enormously important formula.